Alright, this is lesson 95, Algebra 1, called Graphs of Linear or Nonlinear Equations and Recognizing Shapes of Various Nonlinear Functions. Alright, so not a lot of math involved with this. Mostly it's going to be just getting a picture of what graphs of different equations look like. So up to this point we have been doing things like this. Remember that sign? It's basically, if you remember, the y value. Okay, so there is an equation, and every equation of a line can be written like that, with the slope and the y-intercept there. And we've been doing these for a long time, so you should feel pretty comfortable with them. Alright, so whenever you see an equation that's in that form, or basically an equation where there is an x without an exponent, without a number up here, and there's a y without an exponent, and the x and the y are not multiplied together, you're going to get a straight line. If they are multiplied together, not going to get a straight line. So in this case, they're not multiplied, so we know we're getting a straight line. If we have an equation that looks like this, okay, and notice, again, we have our y or our f of x over here, so that's okay, they're not multiplied, but we have an exponent. When you have an exponent that's not a 1 on one of the letters, it is not a straight line. This is called a quadratic function, and this particular one, when you graph it, is going to look like this, or it may look like this, or it could be over here. I mean, it's just one of those little hoop-de-doos, okay? And that's what a quadratic function looks like. If you get one that looks like this, you're going to get an equation that goes like that. And it can be pretty much anywhere. It can be up here, it can be over here. I mean, it's just the shape that I'm wanting you to get familiar with. Okay? Let's see. Let's get rid of some of this and kind of go through some more. If we have a square root function, let's say that we have f of x, and that equals the square root of something. And it could be the square root of x. It could be the square root of x plus 2, or the square root of x plus 2, like that, where the 2 is not under the square root sign. You get a picture that looks like that. Or it could be up here, or it could be down here. Okay, so it just has that shape. We don't care where it's at, and it doesn't have to be the exact shape. In fact, a cube function, remember we said looks like this? Well, it could look like that. It's still the same shape, it's just like a lot weirder looking. So that's a square root function. Then we have what are called absolute value functions, and you've worked with absolute values before, and that is something like if f of x equals the absolute value of x plus 2, or if it's, if it just has an absolute value in it. I mean, it doesn't really matter what it is. If it's an absolute value, it's going to look like this. Or it could be up here, or it could go down this way, okay? But it's going to look like a V, a right side up V, or an upside down V. So just to give you an idea of what these look like. Now, if you ever go into upper level math and you're in college algebra, you will need to know what the shapes of these in. You're going to need to be able to recognize them, okay? So that brings us to 95 B, recognizing shapes of various nonlinear functions. So in the examples below, we shall practice the skill of recognizing and sketching the basic shapes of various types of elementary functions. All right. So the graph of a quadratic function could resemble which of the following graphs? So we have A, B, C, and D. Now if you remember, when we were talking about a quadratic function, they look like the top of page 396. So the answer would be B. Okay? Now if you look at example 95.2, given the equation of the following functions, so now they're giving you the equations, identify the function whose graph most resembles the specified shape above. Alright, so if you look at A is a quadratic. A quadratic always has an exponent, the highest exponent of 2. So the last one, L of x equals x squared plus x plus 1, is going to go with that hyperbola. Okay. If you look at the next one, we are getting that weird shape. That would be the first one. F of x equals x cubed plus 1. That's a cubed function. We look at C, and that's a V. And if we look across the page, top of 398, that's an absolute value function. So g of x equals the absolute value of x minus 2. And then if we look at D, that's going to be a square root function. So that's pretty much all you're doing with these. Let's look at one more, 95.3. Shown below are the shapes of the graphs of various functions. Exact same thing as we did before. So, we have a hyperbola, and so it's going to be the second one over, because that's the one with the squared. B is going to be a cubed. C is going to be an absolute value, and D is going to be a radical. That's pretty much all there is to this lesson. It's not too difficult. It's just recognizing these. And don't get so caught up in memorizing, but I would put them in your notes because you will see these on a test, and it'd be kind of nice to have those in your notes, so it makes it pretty quick and easy to write down the right answer. Anyway, that's it for lesson 95. Not much writing done here.